In this video, we will calculate fault current in this 33 kV network. In this 33 kV network, there are two substations, substation A and substation B, and these two substations are connected by two number of 33 kV line. Each line have same conductor, and conductor impedance is 0.5 ohm per kilometer, and substation A is synchronized with grid. And suppose a three-phase fault occurs at this point, which is 500 meter away from substation B. Now we will calculate fault current at this point with the help of these shaded data. Now if a fault occurs at any part of the system, that fault will be fed by source, which is grid in this case. So the fault current will be supplied by grid, which will follow two paths, one through line 1, another through line 2. But this flow of fault current will always opposed by impedance, which is also called fault impedance. To find fault current at this point, we should first find fault impedance from grid to this point. Now in the case we are discussing about, fault occurs 500 meter from substation B. So this fault is 9.5 km away from substation A, and we consider fault current is IF, and this fault current is fed by grid, and this current is IF in this point also, which will follow two paths, one through line 1, another through line 2. So current through line 1 is IA, and current through line 2 is IB. So ZA is the fault impedance opposing fault current IA through line 1, and ZB is fault impedance which is opposing fault current IB through line 2, and total fault current IF is summation of IA and IB. Now to find fault current at this point, we should find fault impedance from grid to this point, and this network is simplified here. Now this network is further simplified like this, and in this network we will find fault impedance from source to fault point. As ZA and ZC are connected in series, so we sum these two, and this part is in parallel with ZB, so we write this one, and this source impedance is connected in series with this total part, so we sum source impedance with this calculated value. Now to find fault impedance, we will follow per unit system, and in per unit system we should consider a base value, which we consider 100 MVA in this case. Now we will find source impedance, but what is this source impedance? In the case we are discussing about, this simple 33 kV network is connected with a source or grid, and this connectivity is achieved at bus bar of substation A, and the grid means combination of so many generators and transmission lines which should have some impedance, and that impedance is called source impedance. As the grid is connected with this bus of substation A, so the grid or source impedance will also connected in series with bus bar of substation A. And as the fault current is supplied by grid, so this fault current IF will opposed by source impedance. Now source impedance is base MVA divided by fault MVA or source MVA, and base MVA in this case is 100 and source MVA is 3000. So we get value of source impedance is 0.033 per unit. Now we will calculate value of ZA by using this formula, which is Z actual into base MVA by kV square. Z actual is actual impedance of ZA, which is 10 km into 0.5. So this is the Z actual, and base MVA is 100 and our system is 33 kV. So we write 33 here, and calculated value of ZA is 0.459 per unit. ZB part is 9.5 km long. So actual impedance of ZB is 9.5 into 0.5. So this is actual impedance of ZB, and per unit impedance of ZB is 0.436. ZC part is only 0.5 km long. So actual impedance of ZC is 0.5 into 0.5, and it is 0.0229 if expressed in per unit. So as all parameters of this equation is known, so we can find fault impedance between this and this point, which is 0.261 per unit as shown here. To know fault current IF at this point, we will first calculate fault MVA of this point. Three-phase fault MVA of this point can be calculated by using this formula, where base MVA is 100 and fault impedance is 0.261 per unit, which we already calculated. So fault MVA at this point is 383.14 MVA, and by dividing this fault MVA by root 3 and 33 kV, which is system voltage, we can get fault ampere IF, which is 6703 ampere. And as this fault current IF is divided into two branches, they are IA and IB, so we can calculate the value of IA and IB by using current dividing rule. So this is the value of IA and this is the value of IB. So this is the fault current distribution. If you have any doubt, please put it in the comment section. Hope you understand this topic. To watch upcoming videos, stay tuned by subscribing and don't forget the bell icon.